To make sense of the YINT data surrounding the earthquake and aftermath on St. Hamark, we first turned to text analysis. We began by sending the data through a multi-step model to look at sentiment, parse the text based on a variety of attributes, identify concepts, and analyze topics within the text. First, the sentiment algorithm determined positive, negative, and neutral sentiment expressed in the messages. To determine which terms to focus on and which to discard, we parsed the text using automated handling of misspellings and common terms. We also discarded terms that occurred less than 4 times, on our way to isolating terms that would be useful to the task at hand. We then looked for standard concepts within the text, such as dates and times, measures and percentages, money, noun groups, organization and place names, and names of people. We also created rules to look for concepts we had reason to believe would be relevant under the circumstances existing on St. Hamark, such as closure or collapse reports, outages and by whom they were reported, potential fatality counts, family relations mentioned, public buildings, and utilities. When the text analysis was complete, we were able to augment the dataset with enough additional information to begin exploring through visualization. To estimate the exposure a message received and the rough size of an individual user's following, we counted the number of reposts per message. Key user groups were evident in a network visualization in which nodes representing users were connected by mentions with link thickness encoding frequency. This network also revealed groups that only tweeted about very specific topics, such as users that only talked about deals or Department of Transportation updates that always mentioned specific users. Filtering the data to include only discussion about earthquakes and noun groups with adjectives that were synonymous with words like shaking, trembling, and vibrating revealed spikes in message volume. The 3 prominent spikes were the foreshock, main shock, and aftershock of the earthquake. We visualized the time and location of reliable utility outage or building collapse reports to plan emergency response priorities and detect shifts in the type and location of issues that needed attention. To increase certainty that resources were directed correctly, we discarded reports when the reporter hedged or stated that they had heard the information indirectly. Although the patterns we were able to discern in sentiment were unreliable, we used sentiment over time to guide further analysis toward locations with deteriorating conditions as the incident unfolded. Topic analysis across all messages offered potential categories of information that we could track. To make sense of them, we narrowed the time window to look at peaks in activity through the day, often revealing the cause of increased message volume, be it a recurring event like a shift change at the power plant or an unusual event like the earthquake. In emergency situations, such as the response to the St. Hamark earthquake, having a system in place to parse relevant terms, topics, and sentiment could provide a much more detailed look at conditions throughout a geographic area. With experience from this and other disasters, it may be possible to refine the way data is processed in real time to amplify the voices that provide a status and context on the ground.